Alright, ladies and gentlemen, welcome back to Chapter 2, Properties of Matter. Today we're going to go into examples of why substances have the same properties. We will learn and identify the three states of matter, possibly not including a couple of the more advanced ones. We're going to classify physical change as well as chemical changes later. So, to start us off, we're going to take a look at why we study and take a look at these physical and chemical changes. It's not necessarily because I want you to memorize each thing, but I want you to be able to decide what is real and what's fake, what you're seeing if somebody's trying to do a scare tactic, such as many of these videos I have found on the internet. Here's one example of fake food, quote unquote, versus real food. Easy to explain. The one that was scorching was held closer to the flame to begin with. Not only that, but processed cheeses are not necessarily a bad thing for you. What they have in them is a type of gelatin that causes them to be able to hold their structure but still able to melt, which is why if you're looking for something to melt but not necessarily just be cheese and give that flavor, you have processed American cheeses versus the kind that are on the block, which is why the ones on the block generally tend to not melt as easily. This video right here is trying to tell you that people put plastics in rice to make it, to increase the volume. However, rice is actually the cheapest type of grain that you can farm and manufacture, whereas plastics are fairly difficult for us to be able to form and shape, which it would make no sense for us to put more effort into something to put plastic in rice just to try and save a buck, even though it's more expensive to manufacture plastics. So, in case you don't remember anything from previously, calcium is it's magnetic. Oh well, lots of things are magnetic. Your blood is magnetic because it has iron in it. Just because something's magnetic doesn't mean that it is dangerous. Many steaks are actually used, or at least cheaper cuts, use meat glue. It's not toxic. It's not really that big of a deal. But it's used here as a scare tactic. Doesn't make a whole lot of sense. No. Milk and lemon juice, curd. It's a chemical reaction that separates the fats from the whey. It's not a washing powder. It's a chemical reaction. It's perfectly normal. That's how cheese is manufactured. previous one was actually true to a certain extent. It's all milks. All milks will turn purple with seaweed. Not necessarily correct. There are wax coatings to keep bugs and parasites from burrowing their way through on all produce, which is why we are recommended to wash your fruits and vegetables before consuming them, unless you planned on eating a sweet potato raw, in which case I have a lot of questions for you. I think I've had enough of this one, so we're going to move on to 2.1, classifying matter. This is going to be our first keyword in this section, and the first vocabulary word. This is a substance. Substance is something that has a uniform and definite composition, which means that if it is pure gold, this would be a substance. Again, pure substance. Element. An element is the simplest form of matter that has a unique set of properties. So, for instance, in this case, hydrogen. If something is an element, that means that that is the only thing that is located in that collection of atoms. However, most things are found in the forms of compounds, substances that contain two or more elements chemically combined in a fixed proportion, such as we see here. I'm honestly not entirely sure what that's a model of. I don't quite remember. Now, we can also take things and blend them together and create mixtures. These are physical blends of two or more components. In this example here, we have red and blue mixing together to make the color purple. Now, matter, you don't need this vocabulary word. You know what matter is. Anything that has mass and takes up space. Now, when it comes to mixtures, we're going to look at heterogeneous and homogeneous. The two biggest differences in class, we're going to be looking at these separately and try and come to a vocabulary word together. However, for heterogeneous, these are the images that show up. And homogeneous or homogeneous. The differences that you're noticing right here is that a heterogeneous, you can tell the individual pieces apart. Things can be looked at as individuals. We can separate them, things like pizzas. Whereas homogeneous look identical the whole way through. And that's the difference in the vocabulary words. One of them is a mixture where you can pick out the pieces, and the other is one that is the same all the way through, also known as a solution. Again, here is a flowchart for it. Matter is a composition. Is it a pure substance? A mixture? If it's a pure substance, no. If not, it is an element. If yes, it's a compound. Yes, if it's a mixture. If it is not uniform throughout, no. It is heterogeneous, which means that it is separate, like wet sand. Homogeneous, here, tea with sugar. I'm not sure why this showed up, but I guess we can talk about colloids real quick. Colloids are things that are intermediate particles. They do not separate, they can't filter, and they're cloudy. You do need this in your notes. So an example of that would be, whoops, here we go. Examples of that could be milk, or anything that don't separate. So for instance, colloid mixture. Let's look that up. Gelatin, again, would be a very good explanation. Now, as for solutions, examples of each thing would be anything with possibly food coloring. These are things that don't separate, they dissolve, and you can see through them. Also, you cannot filter them. At least not chemically. I mean, without changing the chemical composition of some of them. And finally, we're going to get to suspensions. Suspensions separate over time. Let's see. A really good explanation of that would be salad dressings. Let's see. You can filter them. They have large particles, and they're cloudy. So here we have a chart where we could go through each thing and see how they're similar, how they're different. We're not going to be doing that today. Instead, we're going to move straight on to 2.2 physical properties. So we're going to learn examples of physical properties, going to learn and learn how knowing physical properties can be useful. Going to learn the processes used to separate mixtures. So in this instance, we have a table here of physical properties. And a physical property is a quality of substance that can be obtained or observed without changing its composition. So for instance, we have neon here, the state that it's in. Color is a physical property. Melting point and boiling points. So again, these things here are something that does not depend on changing its chemical property. So compare and contrast, what's the difference between chlorine and other gases? So let's look at chlorine and all the other gases. So we've got oxygen, we have neon. So let's see, they all have boiling points below 0. Their melting points are still below 0. They're below -100 to be precise. They're all in a gaseous state, but the difference would be the colors. Oxygen and neon are colorless. Chlorine is greenish yellow. This is how we can use a physical property to distinguish between them. So what do they all have in common? Again, we just went through it. Their melting points are below -100. Their boiling points are below 0. And which property would be the most helpful in identifying a substance? So if we wanted to identify something, and we wanted to look at their state, well, these three right here are in the same state, but they're completely different. Let's say that I was going to drink something. Let's say that I had 4 vials. Let's see, liquids. So they're all liquids. So I could drink mercury if I'm using liquid only to distinguish them, and that'd be an issue, because mercury is fairly poisonous. The easiest way for us to be able to distinguish between them using a physical property is usually melting points and boiling points. And we're actually, well, I don't know if we're going to have a lab on that or not when we get to ionic and covalent bonds, but that does come into play when we get to that point. So melting and boiling point would probably be the most helpful, especially in this circumstance. So, some examples of physical properties. This is red, so it needs to be in your notes. Number 1 is viscosity. Notice how difficult it is to pour this honey right here. Conductivity, malleability, hardness, melting point and boiling point, and number 6, density, which we will have an entire unit over. Let's go into detail of the vocabulary words of each of these. So viscosity just means the resistance to flowing. Conductivity is the ability to let heat flow. That can also be substituted for electricity. Malleability, to be hammered without breaking, which is what gives gold such a huge value, is that it's able to conduct electricity fairly well as being hammered without breaking. Hardness, to be scratched or scratched. Melting and boiling point. Obviously, if you ever get this question wrong on the test, I have failed at my job. And density is a ratio of mass to volume. Again, we have a unit that we will go into that later. So, physical change is something that changes the properties of materials, but not the composition. So, for instance, this steam right here, it's still H2O, it's still water, but we haven't chemically changed what it is. We're not going to get too much into filtration and distillation right now. We'll come back to that if we need to. So, we're going to use chemical properties instead. Now, we're going to learn how elements and compounds differ. We will learn how substances and mixtures are distinguished, learn why a periodic table can be very useful. So chemical properties. Chemical properties, again, this is a brand new unit, so you need to have that in your notes. Chemical property is the ability of a substance to undergo a specific chemical change. Think about when you're toasting bread. That's not a physical change. That Maillard reaction that gives you that blackened surface, you want a nice brown, that is charring. That's a chemical change that's happening. So examples of chemical properties: flammability, reactivity. So flammability, does it get lit with oxygen? And reactivity, does it get along well with others? How much it's able to react to the things around it. So flammability, if oxygen is present, how easy is it for it to catch fire? Some more. Let's go into the actual definitions. Flammability, ability to burn with oxygen. Reactivity, ability to react with other substances. I have 2 videos here for us to observe. These are going to go into the alkali metals, which I believe we'll discuss when we go over the periodic table.
There are 6 alkali metals: lithium, sodium, potassium, rubidium, cesium and francium. They're all soft metals which can be cut with a knife. In air, the elements quickly become coated with compounds that form on the metal's surface. Here, for example, is lithium. When we slice it, you can see the metallic luster, but the black coating quickly reappears. Sodium is kept under oil to prevent reaction with air. Again, when we cut it, the metal surface can be seen. But this time, corrosion occurs even more quickly. With the next alkali metal, potassium, the corrosion in air is so quick that it's hard to see the metallic luster at all. As we go down the group, the elements seem to react more quickly with air. Now let's see another reaction of the alkali metals, the reaction with water. We'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water in the same way. Let's see an equation for the reaction. Hydrogen gas is produced, and the metal dissolves to give an aqueous cation with a single positive charge. Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a lilac flame. The next element is rubidium. This time we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our 5th alkali metal.
Alright, so now we're gonna see it in a large scale. Obviously, I believe it's francium is the one that we didn't cover in this video, and the reason why is that it's extremely volatile, which means that it will react with a lot of things around it, and it is extremely dangerous.
But of course,
this is
not just the air that they could react with, there are other things as well. It could also react with the water, and this is what we're going to show now. The way you may have seen this in previous demonstrations, they normally throw the metal into some water, but there's all sorts of problems with this because the metal may have grease on it, it may be contained in a glass ampule if it's a really reactive metal like cesium or rubidium. So we're going to do this rather differently. We're going to add the water to the metal, okay? We're going to use the same quantity of metal every time, and not the same mass, but the same number of atoms. So Mark has very carefully counted out the number of atoms, and he's got the same amount each time. So we're going to start off with lithium, and I'm going to add the same quantity of water every time as well. We're going to add 10 mils of water to our metal. So I'm going to take the top off. At the moment they're under argon, so there's no reaction of the metal with the air. Argon is heavier than air, and it's just sitting in the tube protecting the metal from the air, and we're just going to add some water. So this is lithium. You can see that it's bubbling rather nicely. It's forming hydrogen gas. And in fact, we can see the chemical equation for the reaction. It's the same chemical equation for all of the elements. We have the metal reacting with water to form the metal hydroxide and releasing hydrogen gas. So every time it's the same equation. But what we're trying to do now is see if we can tell the difference between the reactivities of the different metals. So out with the lithium, in with the sodium. Now again, it's the same quantity of metal, but does it react any more vigorously? I'm going to add the same quantity of water. All right, so the sodium, certainly a lot more violent than the lithium. In fact, it caught fire. Notice the yellow colour. This is the colour characteristic of excited sodium atoms. So the sodium was clearly having a good time there. Right, potassium. Again, the same quantity, the same number of atoms. We're trying to keep everything as controlled as possible. The same quantity of water. Just as an added safety precaution, I think I'll put this on. All right, so potassium now, and water. Getting more vigorous. Okay, maybe we can, yes, that's a good idea. We'll just remove some of the smoke so you can see the next one more clearly. Now some rubidium. We had an extra blanket, I think. Here's the rubidium in the tube here. We can see the rubidium metal under a blanket of argon. And again, it's exactly the same quantity. Every time we're using the same quantity. This is now rubidium, same quantity of water. Beautiful blue colour. That's the colour of the rubidium flame, remember. We need to wait for that to go. Okay, we'll just wait for this to clear because this is a one-off experiment here. The amount of cesium that we're using is 5 grams and it costs several £100. So here is our cesium. And again, if we just show this on the camera there. So there's quite a bit of the metal down in the bottom of the tube, and again, it's under a blanket of argon. Okay, so it will not react with argon gas. When I take the stopper off, it will not be reacting with the air because the argon is heavier than air. And so that will protect it until it comes into contact with the water. And we've used the same quantity of every metal here, the same number of atoms. Okay. Here is our water. And there we go. Not bad. Oh, I'm pleased that one's over. Good. Right. So actually cesium though, I mean it is the most reactive. There's no doubt it's the most reactive of all of the metals and reacts very, very quickly. It's also heavier than water. Both rubidium and cesium sink to the bottom of water. So that's one of the reasons it reacts very quickly. But I always think that the best reaction actually is with sodium and water. This is my favourite because I think the sodium has more of a chance to sort of build up the tension and heat up. It's much more interesting. So we're going to try some more sodium now on a slightly larger scale in the tank here. Okay. Notice the amount of francium left. It's still decreasing. There's not a lot left now. So that's why we're not going to be looking at any francium. Okay, here is our sodium. Going to drop this into the tank and run away. Okay. Can't see where it is. Oh! There we go.
So that brings us to our next section where we talk about chemical changes. So let's see if I can get this. I need to put this back. Present. Here we go. Alright, so chemical changes. What we saw in the last video produces matter with a different composition than the original. So ways to recognize chemical reaction. These are going to be things that you're going to have to research on your own. If we have textbooks or any reading material provided, they would be a great spot, but you need to know how to recognize chemical reactions. Precipitates are something that I will be demonstrating in the classroom. Precipitate is just a solid that forms and settles out of a liquid mixture. As you can see an example right here and here. I believe this one is a type of lead nitrate. And finally, that brings us to the end where we discuss the conservation of matter, which just tells us that matter isn't created or destroyed. It can only be changed in form. So, it brings us to the end of this week's videos. If you need me, you know how to reach me. Be sure and stay up to date with the information that is required of you currently. It looks like we have 3 assignments for this week. Shouldn't take you too long in total. So, it's been Coach B. I'll catch you guys later.